Hello, Tisana.
Hang on. Can you hear me?
Yes,
Oh, perfect. That's good. How are you doing?
I'm good, thank you. And thank you as well for accepting my request. Thank you
No
so
problem.
much.
No
Thank you
problem
so
at all.
much.
It's very, very good. And yeah, no, hopefully, who knows? Special, let's fingers crossed.
Yes, yeah, yes. Well, and I know it's quite early for me to look for I should say officially a
Pass.
job. Yeah.
Hang on. Session.
Yeah,
Ah,
please.
okay. Yeah, I'm online.
Ah,
Pass.
okay. You are there.
So yeah, don't worry. Bas is going to his room and I'll introduce anything you want
Okay.
me to say about you. And I'm going to basically read your profile and add a couple of bits. Is that okay? Yeah. Yeah.
Okay.
Okay. Fine. Okay.
And Tisana, I also prepared some slides for this webinar, as well as Professor Jochma's biography, so you can refer to that. So I can share the screen now. Um, Allow multiple.
Okay. Sorry,
Yeah,
you. I'm gonna go to back. Okay, he's going to go to his office. Hang on.
yes.
Hang on. That's good. I'm gonna
So,
just plug this back in again.
okay.
Okay.
So can you see my screen?
Oh, okay.
Yeah.
Can you hear
So
me now? Can you still
yes,
hear me? Yeah.
good,
Okay.
good, perfect. So,
Is this for me?
yes.
Oh, so this is for me. How organized are you? Thank you. Okay.
Yeah.
So these are the following courses. So should I say something about these as well, or
Yeah, I can do it. I can do
you could
this
do it?
part. Yeah, I
Okay.
can do this part, and then I go floor to you, and you can start introducing Professor Bas Stockman from here, and then just
I
start.
just need to
Right.
change my settings because I cannot hear you as usual.
Okay. I might keep it, I might not actually read text for text, but it's actually good. Thank you for organizing, Zisha. It's so nice.
Okay.
Even the intro.
Yeah, that's our how to say conventional way.
Very professional. Bas, can I also introduce you to Dina? I don't know if you've actually met in
No,
person.
we are just exchange emails. Hello, Bas.
Yeah, nice
Thank
to
you
meet
for
you.
joining us and thank you for delivering this very interesting seminar.
Yeah.
Well, happy to do so. Yeah. Oh, that's me.
Yeah.
Yes.
I love that.
Dina, you're in the field of earthquakes and structural engineering, or
Yes,
or
yes,
that's what
but with a strong interest in flooding as well. So
Oh yeah.
yes.
Nice.
So
So you should
yes,
see. So Dina runs an environment chamber, a new facility at UCL, also where they test components for different conditions, either side. So you could have
environmental conditions. Yes.
different environmental conditions. So it could be a wall, or it could be. I know that you've done also tapestries and things like that.
Yes.
But you can have, for example, simulate indoor air or indoor humidity on one side and then flooding on the outside, and or wind-driven rain.
Nice.
It's quite nice. It's quite
Yeah.
nice. So yeah.
We have it's related but different. A field facility called Floodproof Holland, which is a site, a basin which you can build in a wall. Davide Wittrich did then flood it and add
Oh, it would be very interesting to
debris
see.
impacts in it,
Oh
and
wow.
so
That
we have
that
an
actually
outdoor
would
facility,
be
less
very.
controlled, less nicely controlled, but it's
Mhm.
outdoor, so we can do a lot of things.
No, but that would be very interesting to define the failure mechanisms of masonry walls, for instance, as the water, increases in depth.
Yep.
Yes, yes.
Super nice. Okay.
Because everybody has, numerical models, but nobody has actually done the testing.
Nice.
It's always surprising to find something as basic as that
Yes.
that you would expect people had done work on and they haven't.
No,
Um, that's
well, now, I was just listening to the news and there was the head of the UK Met Office on the news, basically telling the interviewer was telling him, okay, so the 1.5 degree scenario is gone now.
Oh yeah.
And he got very angry. He said, no, it's not gone. We all have to work towards that because otherwise the planet is gone. So,
Gosh.
yes, it was quite interesting, actually.
So who was it who said it had gone? Is it the MP or
The interviewer was saying the 1.5 degree scenario is gone because
right.
basically this year, again, we will go over.
Up. Yeah,
Yes.
higher.
Yes. And last year we were above and so on. So she was saying, we need to settle for 2.5 or something like that.
Mm-hmm.
Yes, but and he was saying, well, it wouldn't have gone if we had started 20, 30 years ago. And also it was very interesting because he was telling very out of, without half, pulling its punches, basically, that China has got ahead of everybody else. And they are producing photovoltaics, they are producing electric vehicles, they are producing all the technology that is needed in order to go back to 1.5.
Gosh.
And well, and then yes, of course there was a dig at Trump, but he says, Europe has basically, although initially we were ahead of the curve, in the last 10 years nothing has happened, and therefore now we are behind.
Okay.
Sorry to interrupt your interesting conversation, but I think it's time to start the webinar.
Yes.
Yeah.
What time is it? Give it another 2 to 3 minutes so that
Yes.
people. Yes.
So let's start it first and then give more time for them to enter the webinar. So start webinar. Start.
We've about 1 hour in total, right? Because here I see 2 hours scheduled.
Yeah, as long as you like.
Okay.
We have up to 2 hours.
Okay.
People usually hang about for at least 1 hour and a half and so on. So
yeah, I would, if I may, present 40 minutes, then have 20 minutes
yes.
question because there's an event going on.
Yes.
Where
That would be
a friend is promoted to professor.
Oh, congratulations.
Where she appreciates if I show up. It can go a bit over an hour, but
Congratulations.
yeah, thanks.
We just wait a few minutes so we have more people coming in before we start.
So Sean, will my presentation automatically show up after the introduction?
Well, I will stop sharing and then you start sharing your screen.
Okay.
Later. Yeah.
Yeah. Just interrupt if it doesn't show well, or I think we know that.
Yes, we will start in 1 more minute.
Okay. Okay. So welcome to the UNESCO Chair webinar series. Today we'll have a very interesting topic on adaptation to the sea level rise in the Netherlands and around the world. But before today's webinar, I'd like to share the information of the upcoming webinars or courses in the next 2 months. So on the 18th of June, we'll have a webinar with topic of simulating 2D hydrodynamics at a 30-meter resolution for the entire planet, given by Professor Paul Bates from the University of Bristol. And in July, we'll have a 2-day course with topic of community hazard risk assessment tools, structural fragility and vulnerability, and the system reliability mapping. So it's a 2-day course. So on the first day, we'll give you some knowledge and information on the tools, and the second day we'll have some hands-on activities. So please remember these two interesting courses and webinars. You can refer to our website to have more information. So now I will give the floor to Professor Tiziana Rossetto to start today's webinar.
Thank you, Zhexiang, and good afternoon, everybody. Today I have the pleasure, basically, of introducing Professor Bas Jonkman from TU Delft. Bas is a professor in hydraulic engineering in the Department of Hydraulic Engineering at TU Delft, and where he's currently interim head of department. He has his research sort of focuses on hydraulic structures and flood risk, and today he's going to be talking to us about some of that experience, and particularly looking at sea level rise. He is also the holder of the Hagler Fellowship at Texas A&M, and yeah, I'm looking forward to the talk. Bas is an incredible person who has actually worked on many projects on storm surge barriers and flood defenses around the world. And he was scientific coordinator also for a national fact-finding study after the summer floods that affected the south of the Netherlands in 2021. So without further ado, I welcome Bas to provide his talk. Thank you.
Well, thank you, Tiziana and UCL team and all participants for having me as part of this webinar. Zhexiang, can you confirm that my presentation is okay? Then I'll start. It's my pleasure to talk about this important topic, adaptation to sea level rise, and the presentation basically has two parts. What are the challenges and plans for the Netherlands, and some of the ongoing work and challenges around the world. And we start our tour in the Netherlands, and many of you are aware, but to make sure that this is the map of Europe. On your left side, there's this small country, the Netherlands, 250 kilometers north to south, 150 east to west. And a large part of the country, which has around 18 million inhabitants, is prone to flooding. It's located on the North Sea. On the west side, dark blue areas are below sea level, and lighter blue areas are prone to riverine flooding or really high tides, where the River Rhine is coming in here from Germany and the River Meuse from Belgium. And of those 18 million inhabitants, more than 10 are living in those flood-prone areas. Cities like The Hague, Rotterdam, Amsterdam are actually in the west. And to protect these areas from flooding, there's around 3,800 kilometers of defenses, which we'll see later. And because it's a national priority, there's also a large continuous investment budget of around 1 billion euros or more per year to kind of continuously invest in upgrading the defenses, river systems, and so on, which are done in an interplay between the national government, Rijkswaterstaat, and local water management organizations. A bit more about the system, and today we'll focus on more the coastal system. We have here on we call it the Holland coast, North and South Holland, a very nice sandy coast, which is with high, strong dunes, which is kept its present state and volume with large-scale nourishments. We do have, after the 1953 disaster, where a large part of the southwest was flooded, a whole series of dams has been built to what we call shorten the exposed coastline. Storm surge came in here from the North Sea to those islands in Zeeland in the southwest, and dams were built to kind of block that storm surge. And some of those dams are closed dams, and others are, as we'll see in a minute, storm surge barriers, like the Maasland barrier near Rotterdam at the entry towards the city of Rotterdam, those two massive gates protecting or preventing the storm surge going in. And here, if we go more to the north, you see this red line, which is what we call the Afsluitdijk or closure dam, which is a 32-kilometer dam, which was built after the 1916 storm surge. This was still a sea, open sea. Amsterdam's here. And as a response to that, a dam was built to, again, shorten the coastline, preventing that storm surge from coming in. And as you may also know, large-scale land reclamations were built behind it. For a long time, it was the longest dam in the world, but in Korea, a dam was built which was just a few hundred meters longer. This one was finished in 1932. And of course, given the low-lying nature of the Netherlands, there's a lot of attention and interest in the possibilities of sea level rise. And then if we look at the global scenarios, which are also downscale to the local level, we see that projections differ from between 1 and 2 meters in the coming centuries in case of the unlikely low emission scenario with only 1 degree warmer world, 2 to over 5 meters in a significantly warmer world, 5 degrees Celsius. And that there are also IPCC scenarios which project even higher sea level rise, but also the climate scientists indicate, well, we're not sure and they're unlikely at this moment. And well, not surprisingly, a lot of the attention goes to those high-end yet low probability scenarios, for example, 10 meters. And if we would look at the Afsluitdijk, the closure dam, there's the statue of the engineer who invented that, Cornelis Lely. And Greenpeace already put him on a life jacket. And then indeed, if we talk about 10, 15 meter sea level rise, the statue of Lely will be fully underwater. And it will be very hard to defend the west of the country from, well, these orders of magnitude of sea level rise with storm surges on top. And kind of driven by those scenarios, there's planners that really think in a futuristic manner about the future of the Netherlands. Maybe we can retreat to higher ground and build our cities there and have a few floating cities or archipelagos. There's also images like these, Amsterdam underwater, or our other major city, Rotterdam, underwater, which of course trigger a lot of attention and debate, but they focus on these high-end, very far away scenarios. As engineers and planners, we also think let's look at planning horizons. Typically for infrastructure, we take 50 to 100 years, but let's extend it to 150 years and zoom into the sea level rise that we can expect then. And then we are talking about these scenarios. So even in the higher end scenario, 1 to 2 meters. And recently, we've also been working with statisticians and risk analysis to, some of you may be aware of the Bayesian approach, where probabilities indicate a degree of belief that we say, well, bringing together different expertises, how likely are the different scenarios, what is their probability? Can we also come to a combined probability distribution of future sea level rise? And we also coupled that to let's say the cost of, if we do coastal intervention, should we base ourselves on the high scenario where we have a higher cost but build in extra safety, or should we go for the lower scenario? And the outcomes were that, well, if you have those different options and connected to the likelihoods of the scenarios, that an approach somewhere in the middle or a little above the middle, where you kind of balance out over-investing and under-investing, seems a reasonable approach. Well, if you do that, of course, if sea level rise goes faster, you have to come back a little bit earlier. If sea level rise goes slower, then well, you have a somewhat longer lifetime of your infrastructure. But even in those high sea level rise scenarios, we would expect 1 to 2 meter sea level rise in the coming century. And the question is, well, what can we do, and what are our adaptation options in case of the different ranges of sea level rise? Then it's also wise to look back a bit and say, well, how much have we adapted over the past century and in the past decades? And here we zoom into the Zeeland area that was flooded during the major storm of 1953, which also affected the UK and Belgium. And this was the sea defense at Kruiningen before the storm. So a 5-meter high, what we call it, embankment dike with a crown wall on top going to about 6 meters. This is what it looks now. And one of our students made the cross sections of that defense over time, over the last decades. So it started this in green, the 5-meter high defense with the ground wall on top. It was after 1953 upgraded to 7.5 meters, and in a later 15 years ago it was upgraded to 9.5 meters. So already within 70 years this has been upgraded 3 to 4 meters, and in case of an extra meter of sea level rise we would have to add to that. So our previous generations have been able to adapt the defenses in many parts of the Netherlands for several meters within a couple of decades. So, and in that context, adapting for 1 or 2 meter of sea level rise for a defense like this seems feasible, at least from a technical point of view. However, if we go higher, as you see here, we also go wider. And in a densely populated area, country, that may also lead to some interferences with existing functions and spatial planning. I'll plug in my power for a second, just to make sure I'll stay with you for the rest of the presentation. That's why we've been systematically reviewing the various types of coast and say, well, what are the adaptation options and how would they scale in the future? As mentioned, for the Holland coast, sandy coast, there's the flexible nourishment strategy, shifting from really localized nourishments to mega nourishment. This is the sand engine or sand motor, where sand will be distributed along the coast over time. Currently, it's about 12 million cubic meters per year. In case of a meter of extra sea level rise, that would scale to 70 million cubic meters per year. And that seems, in the current context, feasible in the North Sea with a very large sand supply, efficient dredgers that work at relatively low cost. For other parts of the world, for example, Singapore, where the sand is very high priced, that may be a different story. And people are already thinking about, okay, how can we scale up that process? What are the areas where we can win or mine the sand, if you will? What are the environmental impacts? And the expectation is that in the current reservations, at least for the coming 100 years, there's enough sand available, and that more is possible if we would allow more dredging or also use the wind farm areas. And there are also interesting ideas to link it. Dredging is now often done by fossil fuels, to link it to wind energy generation. And of course, we have to think about the environmental effects. I mentioned the storm surge barriers. So these are in other parts, the southwest, these are the gates that are normally open. Here's the Eastern Scheldt barrier to allow tide to go in and out, but can be closed during a storm surge. And these were built after the 1953 disaster. And there in that system, we already see that there's the barrier, behind it the system with intertidal flats and dikes, that those intertidal flats are already decaying because of the narrowing effect of the barrier. because of some other effects. And there, a strategic discussion is taking place. Well, should we improve the barrier by closing it more often and even structural reinforcement? Should we partially remove it and strengthen the embankments around the estuary and to mitigate the environmental effects? Right now, they already started nourishing those tidal flats, basically to help nature a bit. And so for this estuary, we see that the barrier, if sea level would rise 1 meter, it would already close from on average once per year to every week. And if you go even higher in the lower panel, it would even be permanently closed. So there we see that maybe even tipping points will come. A bit more attention I'll pay to well, the barrier that protects the city of Rotterdam. Already introduced the Maasland barrier, 2 giant arms the size of the Eiffel Tower. Now we're looking basically from the side of the North Sea into towards Rotterdam, and these gates close during the storm surge to basically prevent that the storm surge propagates into the Rotterdam area. And well, it's successfully closed every year during September as a test closure, but was successfully closed 1.5 years ago in winter during a winter storm where the gates are being floated in and then sank to the bottom, as you can also see here. So it was successfully closed. We also work with the operators and managers, Rijkswaterstaat, so the Dutch Environment Agency, Army Corps, on developing new expertise and knowledge, because they have challenges in managing this very complex structure. One of our researchers developed a pilot of a digital twin for the Maasland barrier, where actual sensor data on the positioning of the barrier, the floating process, the tilting of the gates are being used, and where also past closures can be analyzed and replayed. Also, if you want to train future barrier operators, are very interesting tools and developments. So there as a university, we also try to step in and work with the asset owners to develop new technologies. But we expect that this barrier built in 1997 can withstand about 0.5 meter sea level rise, and then it will have to close more often and also have some structural effects. So maybe, depending on a lot of factors, in the second half of the century, it will have to be upgraded or even replaced. And that's, of course, a major engineering challenge, but it's also a societal challenge, because decisions that we will make there will also have effect on a lot of the aspects in the city of Rotterdam. There's, of course, well, how are we going to deal with the port that's behind the barrier? How are we going to adapt to changing, developing the waterfronts? So the choices that we make for that system will also impact Rotterdam. And I'm going to show you 3 strategic alternatives that each have different societal effects. The current system with the barrier we call open, but closable, or it's protected if a storm surge comes, can be closed. In the case of the scenario that current Maasland barrier has to be replaced, a new barrier can be implemented. One of our colleagues came up with this design, a kind of half arch shape, 300 meters wide, 150 meters high. And during a storm surge, it would basically be closed and would stop that storm surge from coming in. And of course, this is an enormously challenging project from a structural point of view, geotech, the whole operation, mechanical systems. It's basically a London Eye, half a London Eye, but then that's moving. Note that he also built or designed a nice platform on top that you can, we don't have mountains, but with your cable car, you can go up and then have a nice view over Rotterdam and the North Sea and the whole region. So it could also serve other functions, and some of these barriers, already the existing barriers, are also landmarks and have visitor centers. That's one perspective where we would keep the system open, but it can be closed in extreme conditions. One other option is to move towards a closed dam. And why are Amsterdam and Rotterdam called as they are called? Because they were built next to dams. In those old days, they built sluices, built some houses next to it, started taxing the ships that wanted to pass, and so on. So one of the options is to build a closed dam with shipping locks in Rotterdam. And there's all kind of sites ahead. Seems maybe to some surprising, but we already have this system in place actually at Amsterdam, where we have the giant locks of IJmuiden. And of course, you would need also giant pumping stations in and around it, because the River Rhine that's coming from the back would also need to be pumped out. And there's pros and cons to this model, which was elaborated by some retired Delta Works engineers. It's good for coastal flood protection, maybe less favorable for navigation and shipping. It's good for redeveloping those old port areas where you want to develop housing, because the water level there is more controlled. For environmental reasons, where we like these gradients in an open system, well, probably scores less. So there's also a third direction, which is more environmentally driven, where colleagues from architecture and nature organizations proposed an open and natural system. They say, let's allow sediment to fill the new waterway, it becomes less deep. Let the riverbanks develop with nature, become green zones, and they anticipate that will also block or reduce part of the storm surge propagating into the system. So here we have three distinct alternatives, which have very different impacts on housing, on the city, on nature. And because, at least in the Netherlands, things take time. We have the polder model decision making. We are already saying, well, if in 2050 we want to replace the Maasland barrier, if that would be needed, it takes us about 5 years or more to design and build it. We better start now on elaborating these alternatives, and from a technical point of view, also costing, but also engaging in a discussion with society. Well, what's the future of Rotterdam going to look like? So we also call on our government to say, well, please, we call it design and planning, or research by design. Please work on these alternatives to bring them a step forward and also bring them into the discussion. But it's not only about Rotterdam. If we go a little bit west, there's also bottlenecks in the system. This is the old city of Dordrecht, historic city, 30 kilometers west of Rotterdam, still under the influence of a storm surge. And this is the flood defense of Dordrecht. The flood defense runs through these houses. And if there's a storm surge, they put up these boards. You can imagine if you would say, hey, we need another meter, or we need to raise the defense level. Well, there's an end to this strategy. And there also, and this is the top view from the old city of Dordrecht. The flood defense runs through the Voorstraat, an old historic street. One of my colleagues came up with the proposal, say, hey, if we want to keep that historic city intact, we may also go around it and build a new defense that protects it and connects on this side to the other flood defense. And we build in some smart entrances and gates to allow the small vessels, mostly recreational, to go in. And it could also add value to the city in normal conditions. It's a floating boulevard mounted to a structure underwater. And if that storm surge comes, that boulevard is floating up but still connected, that it becomes a watertight connection. And so we kind of, from engineering design, we propose, okay, let's move forward on these type of solutions. We're not saying, well, this is the solution one must choose, but at least, well, we think it can help to bring perspective for these kind of questions. More in general, we're looking in different regions of the Netherlands on what are the best solutions and the possible solutions. And that, of course, depends on the local setting, local needs. but also and nowadays it's often preferred where we can to apply nature-based solutions. And there's a whole family of solutions. But in general, those nature-based solutions, wetlands, dunes, foreshores, have a somewhat larger footprint and are sometimes only feasible in certain environments. And that's why we also do research to say, well, we do a lot of research on the nature-based solutions, dunes, but also in some cases for dunes, you also need a wide footprint, often hundreds of meters, to build a full protective dune. In some cases, when there's an urban area on the coast, we say, well, maybe we need hybrid dunes with a structure in a dune. But there's a lot of questions on how they perform in storm conditions. And to move forward on that idea, we, our team, colleagues from the department in a research project, built a semi-full-scale, we call it hybrid dune, with several types of structures in the dune, and build it right on that giant sand motor on the coast. And then they say, okay, let's build it in winter and hope we'll catch a storm. And they instrumented it and that we can measure it. Well, the good news is they had a storm. The bad news is it was too successful. They had 5 storms in a row, one even during construction. And they, over Christmas, they have worked all the way. And there's some different sections, the hard defense, a vertical wall, which you don't see in a dune, a defense, hard defense covered by a dune. And that's the before situation. And this is one after one of those multiple storms where it was heavily eroded. And our colleagues Dan Poppema and others are now analyzing that data. And the interesting thing is that these hybrid defenses are also considered, for example, on the Texas coast in other parts of the world. As mentioned, nature-based solutions play a prominent role. Where possible, they're definitely considered and implemented. We had on the Holland coast in the north an old hard sea defense, which looked as the small picture like this. Hard structure on the front, even a vertical wall on top and grass on the back, which now looks like this. A whole dune was built over it, and there the switch was made from the more traditional coastal defense to the nature-based. Yet it was at higher cost, and now also the maintenance dredging is more than expected to keep this landscape in place. And we also look at other hybrid solutions, have a number of research projects on the foreshore solutions where wetlands and other measures play a role in reducing the waves on the embankment that's behind it. And our teams with modeling, with storm observations, are providing the expertise and the modeling and the data sets for the government to say, well, if we would choose such a solution, how much can we, let's say, book in terms of protective value of a certain stretch of wetland? And there are many, in the Netherlands, many other examples where these type of combinations were chosen. So we think the toolbox or the solutions for 1+ meter of sea level rise are definitely there. And we are optimistic that we can scale up and also find the right solutions that fit in the landscape and the needs. Then if we look further, there's these, what are the conceptual strategies for multiple meters of sea level rise? These icons or cartoons have been made. Protect, build big walls and pumps, protect in a more open system with the storm surge barriers, seaward expansion, so build new islands in front of the coast or accommodate or even retreat. But, well, the good news is this was at the cartoon level and everyone has feelings and associations with those. But now the government also made steps in, well, elaborating those a bit forward. One of the strategies is the seaward expansion. And a lot of focus goes to the new islands in front of the Holland coast, in front of The Hague, Amsterdam. But the team that looked at it asked, well, for 2 to 5 meters of sea level rise, what would we do, for example, in the Zeeland? Could we build a dam around it. But then the issue that you have with the River Rhine coming in is you also need to be able to pump out a large Rhine discharge, 12,000 cubic meter per second, partially buffer it in the system, but at some point also pump it out. So you'll need giant pumping stations. Largest ones in the world are now, I believe, in New Orleans, order of magnitude 500 cube per second. Well, here we're talking in the thousands of cubic meters per second. So these type of elaborations have been also made. And then if we even take it a step further, we say, well, even if that's not enough, or we have to scale it up, there's the European, Northwest European perspective, which is the NEAT, the Northwest European enclosure dam, which was not proposed by engineers, because we're often blamed for proposing too technocratic solutions, but by an oceanographer. And he proposed with a colleague, he said, well, we could build giant dams connecting Scotland to Norway, and here one near Calais or France. Well, these are really giant, massive projects. The longest dam in the world is order of magnitude 30 kilometers. So we're talking a length that's 20 times as long. But it's not only about the length, it's also a pyramid or triangle underwater. Well, here it's 60 to 100 meters deep. So you also need to build a huge structure underwater. And we did, with the help of our master students, some interesting initial explorations. They looked at the costs, which were budgeted between 500 and 1,000 billion euros, astronomical numbers. But is it totally unfeasible if we know that the Corona European COVID fund was in the order of 700 to 800 billion? So and it's not a project we have to do in 1 year. It's something we could build over decades. They also looked at the tipping point, that you have your shoreline raising strategy where each country defends its own and raises its own shoreline, versus, which would probably take thousands of kilometers, versus these large dams. And there the student found that potentially these dams become more cost effective than the shoreline raising for above 5 meters. And he also thought about the alternatives and the way to build it. And these are just initial considerations. And of course, the message is also, let's not get there, and we hope we will not need these type of solutions, but they're also out there. So if we would go along the line of sea level rise that we expect in the coming 100 to 150 years, we see the current system is already including a sea level rise margin of 0.5 meter for the barriers, 1 meter for some of the coastal defenses. Above that, those values, particularly the first bottlenecks, are those storm surge barriers where new solutions, either a new barrier or dam, are needed. For some other parts of the systems, the coastal defenses, the dredging, those can be scaled up to some degree. And once we go towards the 5 meter or above, there's more drastic ideas, but those values we probably, if they would take place, would expect, well, depending on global warming, in hundreds of years from now. And we also, in that case, if we go really into the acceleration of sea level rise, we would measure it and have some time to adapt to a strategy. People often ask, well, can we build it? Can we fund it? A couple of considerations. Dutch Delta works were in the order of 10 billion, took careful planning, a lot of learning, a few decades. Another one was the New Orleans hurricane protection system. National priority for the US, brought back the generals from Afghanistan and Iraq from the US Army Corps, said, we have to build this. 1 year of design, then start building. Hundreds of kilometers, $14–15 billion spent, done within 7 years. That's an absolute record speed. In this gradual coastal adaptation, we are definitely talking about tens to hundreds of billions, and something we would plan over decades or even centuries. And people ask, well, can we afford it? At this moment, we're spending about 1 billion euros in the Netherlands on flood defenses, which is 0.1% of the GDP. For 1 to 2 meter sea level rise, that has to be doubled. So then we go to 0.2. Most of you followed the news. The increases in defense spending that are announced or demanded are orders of magnitude larger. And this is also a different form of defense, but well, to put it a bit in perspective. So that's the first part. I think the somewhat shorter part is looking at other parts of the world where I picked out a few examples where we are involved in studying and thinking along. Of course, around the world, a majority of the global population is in coastal and delta regions and also heavily growing. So many regions and cities around the world, and there's a few examples here. Lagos, Shanghai, New York, also Bangladesh, are dealing with this issue of adaptation, increasing defenses, sea level rise, and so on. An interesting, slightly more conceptual note is that there are differences in countries in what we call their risk profile. A meter of sea level rise in Bangladesh has a different effect on flooding frequencies than in Singapore or in the Netherlands. And maybe this is something for the engineers, but this plot shows for various parts in the world the return period versus the water levels. Well, if sea level would rise, if I built a 4 meter high defense in Bangladesh, the steep line sea level would rise a meter, it would increase the frequency by a factor 2 to 3. In Singapore, where I have a very flat curve, a meter of sea level rise would increase it maybe by a factor 100. So that single meter sea level rise has a different effect on the flooding frequency. There's also the other side of that of course the adaptation capacity. Well, if I want to make Singapore a factor 100 safer, I raise my sea defense by a meter. Also, economic growth is different. And if we talk about risk, we have the probability of flooding and the consequences. And one of the strategies could be that if your economy grows, you want to compensate that for reducing the probability. So, for example, if we take Bangladesh, sea level rise is expected between, in the higher scenarios this century, 60 to 80 centimeters. But if the growth continues, the damage will increase a factor of 5. And the associate defense raising for Bangladesh with that factor 5 would be around 2 meters. So in this case, the challenge for Bangladesh to compensate for economic growth is in terms of raising of defenses, if you would solve it through that strategy, larger than the challenge for sea level rise. We're right now working on systematically mapping those two factors of the equations for various parts around the world. There are also areas, Singapore, for example, or Netherlands, where sea level rise is the more significant factor. Well, more generally, many countries around the world are thinking about strategies for risk reduction and adaptation, where this is a more general mix of the type of things you can do, from the nature-based solutions, the embankments, the mitigating measures, but also planning and evacuation, emergency management. And countries find different mixes of those type of solutions. We are from TU Delft involved in a number of countries in studies. One of the examples is I picked 3: Bangladesh, Singapore, and Texas. In Bangladesh, we've been involved with the World Bank in studying the question. Bangladesh is rapidly developing. They are in vulnerable coastal zones where a lot of people are located and economy is growing. Current protection level is that the coastal embankments have is around often 1 in 10 years. So designed for a flooding frequency every 10 years. And World Bank and Bangladesh are working on upgrading those protection levels. And from Delft, we've worked on better estimating the flooding in those coastal polders, forecasting those future adaptation costs for the entire country based on sea level rise, based on changes in standards. And one We've also been looking at the question, well, where in Bangladesh could we include mangroves also as a coastal protection strategy, and maybe even trade it off with embankment raising. And as many of you are aware, mangroves as a nature-based solution well, can contribute by their growth through sediment trapping, and if they're there over 100 or more meters, they will contribute to reducing incoming waves through the sediment and deforestation. And then in some areas in Bangladesh, and our colleague mapped through different layers where do we have mangroves already, where are the sedimentation conditions right, and so on. She mapped a number of conditions, say, well, here are the areas where there are really opportunities to well, promote growth of mangroves and also add it to your coastal protection strategy. And as part of that, World Bank is also considering to engage and support these type of projects. Another area where I'm active myself is Singapore, highly developed, densely populated, but also in relatively low areas. So Singapore now has also defined it as a national priority to well, coastal adaptation for rising sea levels. And they're also thinking about new ways to do that. And they're also expanding land. Singapore's model and growth has been, well, partially driven by also land reclamation. And usually that's done by raising the land with sand and other materials. However, the sand has to come from Indonesia. Sand prices are high. So now Singapore, for the first time, and you can already see it on Google Earth, is completing a polder, a low-lying area with coastal defenses around it and pumping stations to drain out the water, pull out the Kong, with a lot of inputs of Dutch and international engineering firms and also marine contractors. So that was already a novelty by itself, where also the risk questions, well, how safe is it to live in such a polder? How high should we make the defenses and how strong? And I believe that Singapore now has adopted the most stringent safety standards for their coastal defenses in this polder around the world. But they already have the next land reclamations in the planning or on the drawing board, which would be the Long Island land reclamation on the eastern side of Singapore. At this moment, considering more traditional land raising reclamation with a water reservoir here, where large-scale pumping stations, like they already have now in the Marina Bay Barrage, would be built in a nice lagoon freshwater reservoir here. And of course, that's also a challenge by itself, because one question is, well, how high and safe and do we make those land reclamations? But also it's in an area with tropical rain. How do we drain them? And how do we make sure that's a balanced system? And we're now engaging in some further studies to look, and often these questions from coastal flood protection, pluvial rainfall, water storage are still treated in a somewhat sectoral manner. They're each optimized for themselves. And now we're taking a little bit more integrated approach where we say, well, how could one design those land reclamations where with objectives for coastal protection, dealing with pluvial rainfall, water storage? What does that mean for the design of the land reclamation, the shape, the pumping stations, and how do we integrate that, optimize that system? And that's something that we're now engaging in also with partners in Singapore at the universities. As a final example, and it's an area that I've worked on a bit more myself, is the area around Houston in Texas, where this is the Gulf of Mexico or America, whatever you prefer. And Houston is one of these economic hotspots in the US. If you take the greater Houston area, it has around 6 million people, and also a large, they call it energy industry around it. And on that Galveston Bay, a lot of the industry is located. This area is also prone to storm surge flooding, hurricanes, similar to New Orleans, but well, different from New Orleans. They have much less protection in place. And here you see a schematic hurricane pushing up the water from the Gulf up to those coastal barrier islands where the city of Galveston is located, but also pushing the water into that Galveston Bay, which is the same size for the Dutch as the Lake IJssel, IJsselmeer, and also leading to local wind setup. And they're right now working, and for these reasons, its location, Houston, is also known as the flood capital of the US, from inland rainfall flooding during Hurricane Harvey in 2017, but also from those storm surge floods. This is an image from Hurricane Ike, from one of the barrier islands, where, if you look carefully, just one of those houses was standing and the rest was demolished by storm surge waves and wind and so on. And in 2012, we were approached by academics from Texas A&M that came with a map with a few lines on it, and they say, well, we have this idea of proposing a delta plan that shortens the coastline. We are thinking of building embankments or dunes here and a storm surge barrier here. And they say, well, in Texas, they think we're nuts. What do you think? And we say, well, it looks like our approach for the delta works, shortening the coastline. So we say, well, sounds interesting. Let's study it with students. And that's how we started. And over the years, a collaboration developed on studying the various components of those plans, where one of the most challenging components is this opening where the circle is, which is called the Bolivar Roads, which is the entrance to the port of Houston, the Houston Ship Channel. And say, well, what can we do there to build a system, for example, storm surge barrier, that protects when the storm surge comes, but leaves the system as open as possible in normal conditions, because we want the shipping to be going in and out. We don't want to interfere the Port of Houston, and we want to have a minimal impact on the environment, on the sediments, and so on. So we want a system as open as possible. Over the years, many students and others came up with concepts, and the plan got more support locally. The Army Corps and State of Texas started also elaborating it. And this is from a few years back. They're one of the designs for that storm surge barrier in Bolivar Roads. And it would be one of the largest programs in the history of the US Army Corps. And this basically a double Maasland barrier with the sector gates, with here the vertical lift gates, a bit similar to the Eastern Schelp barrier. So that was the official government plan, which was also approved, supported by the US federal government. Only one detail is that the plan is supported and approved, but no funding to design and build it is yet appropriated. And then discussion started a few years ago that the Houston pilots ran this plan in their simulator, and out of the 15 runs that they did, well, there were 3 collisions or near misses. So they said, we're unhappy with this gate proposal. They're not wide enough. They're 650 feet, 200 meters. There's an island in the middle, the location. So right now we are also supported by the state of Texas with the academics from A&M, Galveston, and others from the private sector, working on studying, well, can we improve, optimize this plan, where we move location so it's in a better alignment with the ship channel and the turns that they make, where we change from the 2-gate opening with the island in the middle to a single gate opening, where we would have the current Maasland barrier is around above 300 meters wide. Here we would want to go for 400, 450 meter wide. Everything is bigger in Texas, they say. Well, those kind of studies are ongoing and also contributing to the planning. Well, in the end, it could look like this. So combination of the very large Maasland barrier or sector gates in combination with the sluice gates. And then, of course, here the navigation is key, but as I mentioned, also the environmental impact. Where the Eastern Schelp barrier closed the cross-section for more than 50-60%. Current gate designs here would limit that to around 10%. Still could definitely be impact, has to be assessed, has to be studied, has to be discussed. But also in this new generation of Delta works, of course, well, we try to do better. And of course, it's interesting to contribute to these kind of plans and ideas internationally, but also in the Netherlands, we can learn from these new mega projects for our planning of our next generation of Delta works. So in the end, a more complete system plan has to be developed and planned, which include both more the structural elements, the gates, but also many nature-based solutions along the coast. The concept of the hybrid dunes, remember where we did the test, is being studied. And then even when you have protective features here on the coast, you could still have wind setup in the Galveston Bay, where the nature-based solutions, the wetlands and so on the bay shoreline would definitely play a valuable role. So, well, that also gives us energy and new ideas to continue studying those. Well, I think we're coming towards the end of the talk. We once more return to the Afsluitdijk closure dam in the Netherlands, the statue of Lely. There's an inscription on it that says, "A nation that lives builds its future." So we're studying and building the future and also the solutions for the future, where a lot of new academic knowledge is needed. For the Netherlands, if we talk about 1 to 2 meter sea level rise with all the solutions and the costing, we're confident that there's good options. Yes, we can. It's definitely going to be a large mega effort. And also our government, because we need the time for careful planning, it's really time where we have the first bottlenecks, the barrier in Rotterdam, really time to start now with planning and elaborating those regional strategies. And we need new innovative solutions, Delta Works 2.0, well, to do better. Here I presented a somewhat engineering perspective, but of course we must do that in a multidisciplinary design setting, including environmental aspects, governance, economy. Well, a lot more will be needed. And I'm also convinced that international collaboration, helping each other, learning from each other, is definitely key. And that's why I'm also glad to talk to this very international audience about these topics today. So with that, I want to close this part of the presentation, and I would welcome any questions.
Thank you, Bas, for a fantastic presentation. I've learned a lot, actually. So this is, I've got many questions myself. However, I invite other participants if they would like to first ask some questions. You can either write them in the chat, or if you wish, you can raise your hand and I will call on you to unmute yourself. No? Shall I start?
In which case, I might.
Oh, please, Dina.
Wish to ask a question. Thank you. First of all, Bas, thank you very much for this very insightful talk on how we are going to make it in the next century, basically. One thing that intrigues me is, well, I have two questions, but the first one is about the issue of the different rate of return period for the same level rise, i.e. 1 meter or 2 meters, depending on the location. So you show that Bangladesh and it's a more drastic and more often return period, the sea level rise of 1 meter, than it would be in Singapore or in the Netherlands itself. And the other one was more on the very large size intervention that you foresee possibly in the Northern Sea and in North Europe. How feasible are they with the current technologies? and how feasible are they with a different type of energy productions, and therefore the way in which we can then apply that to civil engineering and hydraulic engineering actions.
Yeah, but to start with the last, I think you referred to this Northern European enclosure dam.
Yes.
Well, I'll leave it at this slide, but yeah, we started to look a bit at that solution. It's as I mentioned, it's a factor 10 longer more than the current scale. You would, for example, you would need the world's production in sand if you would build that long dam in sand. But again, it doesn't have to be done in 1 year. We also looked at other, but then you would have at the base, it was hundreds of meters wide. We also looked at caisson options where it would also extend to some degree, and most of the parts is 20-meter deep. Well, there we can, within the Tuas caissons in Singapore are in that order of magnitude. So a large part of it would go with conventional technology, but again, at larger scale. There's areas like the trench near Norway where it would really expand above that scale, and you would really build a huge sand pyramid. There's also engineering challenges, earthquakes in that area. Well, the first indications were we're not sure it's technically impossible, but we haven't proven the opposite yet. We were not asked to do yet by the European Union. Say, hey, it's a nice plan. Can you elaborate it? It's the last refugee option. The part of energy production, it can be combined with, of course, wind energy generation. There's at some point we can also think about tidal energy generation. Those kind of options. So I think there's possibilities, but in the end, yeah, it is a mega project. Will have a large impact on the North Sea. Let's hope, or let's make sure we will not get
How
there.
mega it is compared to some of the projects that are going on in the States or in or in Asia?
Yeah, it's orders larger. As I said, the longest dam is 30 kilometers. This one would be 20 times as long.
Yes.
The Texas Coastal Project is now budgeted at, it's the most expensive civil works project, $50 billion. This would be at least 500 to 1,000. So it's really orders of magnitude beyond what is currently done. And the question about the return periods, what was your?
I was just I would just try to understand why the different curve of return period against the rise have a different steepness. It wasn't entirely clear.
Oh yeah.
This, yes.
It's because of the I would call local factors. How deep and steep is the foreshore? Singapore has deep water, and then you have limited setup. That's one example why it explains that in Singapore the setup, if we have stronger winds, is only adds 20-30 centimeters. It's related to the storm climate. Bangladesh and New Orleans have these hurricanes, cyclone systems with much higher wind speeds than we have in the Netherlands, probably contributing to the steep curve. The Netherlands is in this North Sea somewhat sheltered basin, so that's really up to those local environmental conditions that dictate the type of storms, and they're increasing these curves.
Thank you for clarifying.
Are there any further questions from the audience?
There is one in the Q&A.
I cannot see.
So William Turner, I don't know if you want to open your mic. Hi, William, please, you can read or just, yes. introduce yourself and just give us your question. Your mic is closed at the moment.
Maybe we can read it out for him.
Yes.
So
I'm asking to unmute, but yeah, it's not working.
the question is, how does the cumulative impact of land reclamation projects across multiple countries affect global sea level rise?
So yeah, I haven't done the estimate, but my estimate, if you would say, if I put in a bathtub an element and then the water rises, or if I sit in my bath, the water will rise. Here, I think if we look at the global oceans and in the size of the land reclamation, it's really a negligible effect. Would be my expectations. There's many other aspects to land reclamations, from environmental effects. Where do we get the sand? They need to be taken into account.
Thank you. I will have a question in that case. I can't see any coming up at the moment, but please do add your questions to the question and answer tab. So you talked a lot about nature-based solutions, but in many cases, not as the ultimate solution. You know, in many cases, they need to be accompanied, or there needs to be some sort of a hybrid solution between, say, engineering protection as well as some of the nature-based solutions, partly because of land, etc. In many developing countries, however, with large exposed coastlines, Indonesia being one, for example, where you know the costs of building engineered defenses is sometimes prohibitive, and also maybe not desirable from an aesthetic point of view. I mean, what sort of assurances, or you know, how effective can we really say nature-based solutions are in such contexts, and what reliance can be had on them? I guess it's, yeah.
Yeah, good question. Plus, there are several elements to that, but well, one important step is that we say, well, do they fit in the local environmental physical system? Sometimes if there's no nourishment, or if the mangroves don't grow, or the wetlands decay, that's an important question. Then we're also studying, well, if we have or build those nature-based solutions, how much will they contribute to wave reduction? So what's their coastal protection value? Of course, also look at the co-benefits. So in many areas of the world, we are involved in projects in Indonesia on mangrove restoration. They definitely provide a lot of services and benefits. And up to a degree, a level of coastal protection. But there, I think the challenge is, if you want to go to higher levels of coastal protection beyond the 10-year return period, yeah, you need to add some probably hard elements to it, or adapt the buildings behind it. So yeah, there are limits to the protective value. Maybe one exception is the dunes, either natural or nourished, which you can, and in the Netherlands we have dunes that are designed to withstand storms with 10,000-year return periods. But then you talk about a dune system 500 meters wide, 10 meters high. You need a lot of dune, but there are also great recreational areas. So yeah, the answer is that yes, they have a lot of value. There are limits to it. And in the end, it's site specific. But I think the good news, also the example from Bangladesh, that they're now really much higher on the agenda as something that needs to be considered in the earlier stages, and if possible, even preferred.
Thank you. I did have a follow-up question, which is, in many of these calculations, or many of the cases, you know, one extreme event is taken into account, or a extreme storm. But as I guess the example of the case of your hybrid dunes, extreme events can happen one after the other in sequence. So often, you know, where you don't have time to recover the defense before the next one hits. Is that taken ever into account within the design of these structures, or is that still a gap, I guess, in the research?
Yeah, the short answer, it's a gap, both in terms of just sequential extremes of the same type, as well as the compound events, we said that are separate worlds, coastal flooding and pluvial, during tropical cyclones or hurricanes. They happen at the same time. So I think that there we can all make a step to better assess those. We did do for the sand engine nourishment, the large some initial studies on these subsequential storms and what that would mean in terms of buffering area and restore. But ideally, we want to we talk a bit more broadly, holistically about resilient systems and redundancy. Yeah, we also want a system, ideally, that if it's overloaded or has this first storm, it's not immediately brittle collapse afterwards, but still has some capacity. And I think that also with the dunes and the hybrid dune system, something that was taken into account.
Thank you. There's a question also that has come up.
I'll try to open the microphone for Waka. Or maybe you should be able to speak now.
I hear this. I see.
Hello, hi.
Please introduce yourself and
Yeah.
give us your question.
So I am Pakar. I am doing MS by research in disaster management from Indian Institute of Technology, Guwahati. So I had this question like, how deep do you penetrate the society in assessing the impact of these projects on people? I mean, to what scale, to community level or what? Because this is such a huge scale thing, sea level rise. So do you assess it just based on a structure or livelihood as well? Or any such a study or project can you suggest where this have been done?
Well, yeah, thank you. It's a great question. The risk is, of course, is typically as engineers, we look at maps and stuff and we draw and say, hey, here's the solution. But I think we're changing. Maybe our students, our community is aware, paying much more attention to that. So it always starts with good conversation and inventory. What are the societal needs and what do people experience? What do they want? And can we then find solutions that accommodate most of that? And one example is the coastal protection near Houston, Texas, the barrier islands, where we talked a lot to the local stakeholders, homeowners who live on the coast. And they say, hey, we don't want a wall in front. We don't want a big dune that goes where our house has to go. We understand there needs to be coastal protection. And then we start thinking, well, maybe this hybrid dune concept, which has a smaller footprint, is a bit lower. The homes are on stilts, would still offer for the homeowners a value and would also fit in the landscape. But that's just one example, and I think this is definitely an area where we must do more to societal driven, stakeholder driven design solutions are crucial. And also when we develop something, feed it back, ask for feedback, and we also need time for that. That's for Rotterdam. I say, well, we have to start to allow for those discussions and engagement.
Thank you for your answer.
Thank you. There is one more questions from Nazimuddini. Again, I will open your mic if you want to introduce yourself, please. Nazi, yeah. Please, I think you can speak up.
Hi, thank you. Am I audible?
Yes.
Yeah. So thank you so much for presenting all the efforts you have taken in Bangladesh. We know that as nature-based solution in Bangladesh that we are afforesting the coastline, and we are doing mangrove forest, which are really working in the some of the southwest coastal zone of Bangladesh as barrier for in some cases as barrier from storm surge. But we have seen that the sedimentation rate on those areas are very high. And due to that, we have seen that in the coastal zone, in the coastline, the sedimentation rate, due to the high sedimentation rate, the elevation is higher than the mainland. And we have seen that in some of the polders, namely polder 32, 33, 34, in those region, that the riverbed elevation is higher than the mainland.
Yeah.
And you know that the annual rainfall of Bangladesh is 2-3 times than the Netherlands. So water stagnation is also now a very, very big problem since 1980s. Afterwards, we have seen that in some bill areas, in the some polder areas, that people started practicing the tidal river management that allows the sedimentation inside the polder. And now that we have seen that if these areas are kept open for 4 or 5 seasons, there are sedimentation happening, but due to the flow conditions, due to the velocity and other characteristics, in some places sedimentation is ongoing. But if the pole at the very upper level, we didn't see that there is a very significant of amount of sedimentation happened. We didn't see about it. So most of the nature-based solution we have taken, these are not that much of effective in Bangladesh. Can we find any other solution for this?
Yeah, it's an intriguing question. I recognize some of the elements with my limited knowledge. Bangladesh, some of the elements that you present. It's interesting. In the Netherlands, they also thought of this tidal river management, opening polders, letting them silt up. But there would take decades or even 100 years to silt them up. Just showing the different solutions work differently in different countries. I know at part in the Netherlands, some of the areas outside the polder are higher than inside, and that's what you then need as solution is the pumping and the drainage system. But as you mentioned, that for Bangladesh, if those rainfall intensities are so much higher, that can become challenging. Even you can within that polder then say we need larger buffering areas to accommodate that, so not build or use all the land for other functions. I know in Bangladesh, one of the lines of thought is there's the existing polder system, but you could also zoom out and say, well, can we cluster certain polders that together they become a more efficient and less risky water system? But to be honest, I don't have like a silver bullet solution. Oh, if we do this, it's that will play that will solve a lot of these issues. But I think being aware of them and then trying to find a solution, also trying to limit subsidence by groundwater management are all important elements.
Thank you. With that, I think I can't see any further questions unless there are any burning questions. I think I would like you to join us in thanking Bas for this really, really interesting presentation, which touched upon many different areas, many also countries of the world and different solutions. And thank you for the stimulating presentation and also the stimulating discussion following. So thank you very much. We will draw it to a close. Thank you.
And as usual, you will find the recording on our webpage and on YouTube. So for further reflections and thinking. Thank you very much, and see you in 3 weeks' times with the next webinar. Bye-bye.